Alright, I'm live again. I just couldn't resist doing my second stream of the day, and I will be celebrating the sun once again, and this time I'm going to try and watch myself while I'm streaming so I can read your comments a little bit better than before. Not that any of you even here yet. Ok, un momento. Oh, no funciona. Okay, that's not working. Never mind. Oh, look, people here. Hello, 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 hello. Good to see you all again. Are you looking forward to learning some more about our sun? All right, I'm just going to start talking, and then people might watch, people might not watch. Either way, I'm going to enjoy myself. Oh, hello, Ruby Milner. Oh, thank you. It's amazing to know about it all. Oh, I certainly don't know it all. In fact, I was just looking back through my own videos, and I forgot what some of the things I learned were. All right, like I said, I'm going to start. So, my favourite fact, perhaps of all possible facts, is that me and you, we are all made of star dust. What do I mean by that? I mean that stars literally died in a supernova explosion, probably about 5 billion years ago at least. And all that time later, you and I are here. So all the things you see around me, from the light and that little guitar, to this building, to the whole planet, we are all the remnants of previous generations of stars. Because the universe is roughly, I think it's 13.8 billion years. That's about how old we think it is. In fact, we can see light from 300,000 years after the creation of the universe. But we can't see back any further than that, because before that there wasn't light, or it was too thick and the light couldn't escape, gravity was too strong. I can't remember exactly, but anyway. We've seen light from billions of years ago, and stars have been around for, I think the oldest star or oldest galaxy we've seen is 12 or 13 billion years old. Hence, we know that the universe is at least that old. Anyway, what was I saying? We're stardust, right? What did I mean by that? So, our sun won't blow up in a supernova explosion. I don't know if you're sad or happy about that. Either way, we're not going to be around to find out unless we learn how to live forever. That's another subject. So, if if a star is big enough, then what happens is maybe I should say what a star does first. Yeah, that'd be better. So a sun or a star essentially burns a basic element into a more heavier, complex element. Most stars are made of hydrogen, or mostly are made of hydrogen, because hydrogen is the most simple element, and it is the most abundant element in the entire universe as well. Which means that, if you went to a galaxy far away, you would find that most of the stars there are made of hydrogen too. And we know that because we can see it in the starlight that reaches us. And we found a way to decode that starlight. So we know there's lots of hydrogen. The second most abundant element in the whole universe is helium, which is no surprise because hydrogen, when you crash or force two hydrogen atoms together, the end result is a helium element. Now, we call this process nuclear fusion, and I made a video about this to explain it a bit better, which nuclear fusion requires a lot of force and pressure to make these two atoms collide, because an atom is made out of mostly empty space, which, by the way, means you and me, we're mostly empty space, believe it or not. It is difficult to explain, JC. Thanks for making me feel a little bit better about myself. I tell you what, people who know about nuclear fusion probably can explain it well. But bear with me. So, nuclear fusion, right. Atoms, they're mostly made of empty space, but inside the atom are three particles. We call these particles the electron, the proton, and the neutron. Oh, I love you too. These three particles, two of them live together in the center. The center is called the nucleus. Now, some of you might be jumping ahead and thinking, nucleus, nuclear fusion must be linked. You'd be right. The other particle is the electron, and that orbits around the nucleus. Now, to make two nucleuses from separate atoms collide is like the equivalent of getting two stars to collide. There's so much empty space. Well, there's so much space. I shouldn't say it's empty. It's not totally empty, but it's very quiet. It's I've lost my train of thought now. Oh yeah. So if you take two stars and put them together, that's equivalent to two nucleuses coming together because of how much space is in between them. Atoms are mostly empty. We are mostly empty space. Plus, there's a force. I can't remember the force. No, that's something else. See? I don't know everything. For sure I don't know everything. Right, nuclear fusion. Okay. So, it requires great pressure to force two nucleuses to collide. And during that collision, what you will get is the birth of light itself, which is pretty spectacular because light does come from something. It's not just always there. And the birth of the light is called a photon. Light is made of particles called photons, and the photon is what you get from the nuclear fusion reaction. Because as those two hydrogen atoms collide, or other heavy elements collide in nuclear fusion, a little bit of energy is lost, and that is what light is. Now, I don't think it's possible to see a single photon of light because they're just so small. So I wonder how many photons of light are actually hitting my eye from my light right now, or from the sun during the day. Probably every second you're looking at billions and billions of photons of light. Because I know for a fact that particles from outer space, from away from Earth, pass through us all the time. Like my thumbnail alone has trillions of particles flowing through it continuously, but I don't feel a thing. Those particles, by the way, are called neutrinos, which I haven't done a video about yet, and that's because they're a little harder to explain. They also are born from stars, and they also travel very close to the speed of light because they're not very heavy. And they pass, trillions of them pass through my thumb every single second, and yet I don't feel it because they don't react often with the particles that make me and you. However, we have built these great big science experiments underground to capture neutrinos. Now, the reason it's underground is because there are so many other particles from space that hit the Earth, but not all of them can pass through the Earth, whereas the neutrino can. So these neutrinos, we detect them by putting lots of liquid, like a huge swimming pool, underground, where other cosmic particles can't reach, but neutrinos can, and every now and then they'll interact with a particle and it will make a little flash of light in the swimming pool. And that's how we know they exist. Pretty amazing to then know that there's so many of them around. Like, interesting to learn a story about that guy who discovered the neutrino. I have, but I've forgotten it. All right, I'm going to read some comments for the next sort of minute. So if you want to talk to me, now's the best time to do it. You love science, Emma. That's great. I love science too. I think the reason I love science so much is because you learn more about the real world and the place that we live in, how things work, like my body and things. What is the hair channel called, Emma? I don't know what that means. Any more comments before I ramble on some more about geeky science stuff? Well, Sammy, go out of Imogen, please. No. What's it like growing up with Rye when he can't spell? You know he can't spell his own name? His name's Ryan. I actually call him Rye Pie. So that's because my mum nicknamed him that when he was a baby. Am I still going to fight you, Meg? Yeah, name a time and place, I'll be there. Any more? All right then. That is my cue to do more talking. Let's see. Okay, back to nuclear fusion. So I told you it requires great pressure to force these nucleuses to clash together. So therefore, you must have an attractive force. And the most obvious attractive force we know of is gravity. Now, everything has gravity. Even I have gravity. This raspberry here that I'm eating has gravity. And in fact, somewhere between me and the raspberry is the central point that we both orbit around. Now, because I have a lot more gravity than the raspberry, that point is probably somewhere very close to me, like not even a millimeter off my body. This is true for us and the planet. So right now, not only is gravity from the planet holding me to Earth's surface, but I'm also affecting Earth's gravity. You might have heard, what if every human jumped all at once? Would it create an earthquake? Well, turns out there's not enough humans. Hola, amigo. Estoy hablando en un video. Très bien. Come in. Hey, come. What's up? Hello. I am talking to some people on the internet. Oh, Star Wars, yeah. I bought that to improve my Spanish.
Oh my gosh!
You boys want to have a look at it? You can.
Yeah.
And then this I've made as well, and I'll explain that another day. It's a rocket. Yeah, it's a rocket. And that's supposed to be the moon with its craters.
Please, cut.
You should get out.
Who is?
No, I want to talk a little more. I'll do 10 more minutes.
Who is that?
That's just some friends of mine. I think they're probably saying hello. Oh yeah, they are so cute.
Hello, I'm Danny.
They're not that cute. Right, how you doing?
Hey.
Fuera!
No. Oh, thank you.
Yeah, see you in a bit, boys. They are great. Yeah, just quickly, if you didn't know, I'm living with a lovely Spanish family here in Spain. And those are the two boys that I mostly play with at the park or help them learn some English. What? Leave me alone. What? You just put it down on the floor. Sorry, this is not very professional, but I'm not professional. Okay, I can't remember where I was. Everything has gravity? Yeah, something like that. Anyway, once upon a time, in a galaxy far, far away, there were some dust particles. In fact, some doesn't really do it justice. There were loads of dust particles. Like, think of the biggest number you can think of. Trillions. And it's much more than that. Anyway, we call this cloud of gas and dust, and some other chemicals too, we call that a nebula. And in fact, I recommend you doing a quick Google search to just look at some of the beautiful nebula we have in our galaxy. Truly spectacular. Anyway, these are the places where stars are born, because they have all the raw materials and to make a star. So how do you get from clouds of gas and dust to becoming a star? Well, obviously gravity has to play a role. Now, I guess slowly over time, as dust and gas got closer and closer together, the bigger it got, the more it would attract other gas, and you could see it slowly becoming a star that way. But I prefer the theory that a supernova explosion nearby to the nebula, or perhaps even inside of the nebula, this let out huge amounts of energy, and that is what triggered the birth of a star. Perhaps even that's how our sun was made. Anyway, eventually these gas and dust particles, their gravitational attraction to each other means that they start to orbit around each other, like me and this raspberry would orbit around. Because everything has gravity, like I said before. Well, everything with mass has gravity. Space itself is massless, so it doesn't have gravity. So if you can picture all these rocks and ice and things getting bigger and bigger as more of them clump together, as they start to orbit around their center of gravity, eventually you've got really big objects like planets and stars. And the moment the star is born is when the first collision of particles took place in nuclear fusion and a bit of light was emitted. But to get to that point still requires so many particles, and they have to be packed really close together because remember, they're mostly empty space. Plus, I should mention, these particles would have to be moving pretty fast too to be able to be forced together. Anyway, the photon is born when nuclear fusion takes place, and the photon travels at an incredible speed. The speed of light is 186,282 miles per second. Now, if I said per hour, that would have still blew most people's mind, but it's per second. I can't remember exactly how far light travels in a year, but it's around 6 trillion miles, which is a long way, but it's not even long enough to reach our nearest star. The nearest star, obviously other than the sun, is Proxima Centauri, which is something like 4.2 light years away, which would make it about 25 trillion miles. So if I was to live stream to somebody like an alien perhaps on Proxima Centauri, the nearest star, well, not on the star because they'd probably burn, but on a planet orbiting that star, then it would take over 4 years for my message to reach them, traveling at the speed of light. And then they would reply, and it would be 8 years since I originally posted that video before I would have seen that they liked it, commented, and subscribed. All right, I've seen a lot of comments flashing up. Let me have a look. Go on, then. Send some my way. I'll read them. I'm sure you can understand. It's hard for me to blabber on these huge topics and read your comments simultaneously, but I appreciate all the love. Oh, you don't want to see our cards. Oh, very funny, Meg. Very funny. Hey, my cousin, Dan Jones. What's happening? That is a long time, Brody. That's right. That's why, even if we discover signs of intelligent life in other planets, by that I mean aliens, it would be very hard to communicate with them because even at the speed of light, messages would take years to get there and then years to get back. Plus, we don't speak the same language, well, I assume, unless they have Google Translate too. Oh, I can't believe my cousin's watching. Good luck with your test, Char Gabs. I don't know what to call you, Char or Gabs. These raspberries are great. Tell you what, it's good to have a rest as well. Get sick of my own voice. Char. Okay, hello, Char. And Emma, you failed your test. All right, good for you. I guess it only really matters if you cared about passing the test. Well, sorry, Milena, I cannot share these raspberries with you. But I will enjoy them on our behalf. Hello, Ashwini Ramesh. Now, I haven't come across your name before. Are you a new subscriber? Welcome. Okay, let's do a quick review of what I've spoken about so far. Well, before I do though, yes, I am your science teacher, just on your online teacher. Hello, Amy McCandlish, another new name I haven't come across before. Thanks for saying hello. Okay, right. Let me try and concentrate. I can't read any more comments right now. The review, right. So, I told you that a star is born when it first emits light. But to do that requires incredible amounts of particles to be occupying the same space because it requires gravity, which everything that has mass has, to force them together. And particles themselves are practically weightless. But if you have trillions and trillions and trillions, then you start to get more mass, more gravity, and eventually you'll get two particles collide. But it's not just colliding because they're mostly empty space too. But it's when their nucleus inside of them, they collide, and then a little bit of energy gets lost, and that's the birth of light. And when they collide, they actually form these heavier elements. Now, interestingly, we're made of the same elements as the planets and the stars, just in different amounts. That's not entirely true. There are some things the planet has that we don't, but we share similar elements. And we get them from stars because when stars are hot enough, they don't just make helium from hydrogen, but they can make heavier elements like oxygen, carbon. Now, our sun itself, at the moment, isn't hot enough, which is a crazy statement to say that our sun is not hot enough, because you only have to go outside in Spain, where I am, and look at my colour of the skin. I'm brown. I'm so brown that a man came up to me yesterday and asked me for directions because he thought I was a local. It was a special moment. Anyway, the sun is very hot. The temperature inside the core, where these particles are fusing together, can get up to 16 million degrees Celsius. Now, I don't know about you, but I can't really picture 16 million degrees Celsius, because for me, a hot day is when it's 30 degrees Celsius. 16 million? That's a lot more. And on the surface of the sun, it's 6,000 degrees Celsius, which, interestingly enough, is the same temperature, kind of, as our planet in the core of our planet, where the lava comes from. That's just an interesting coincidence. I'm deciding where to go. There's so many interesting facts to share. I'll just briefly mention a mystery. Okay, so let's imagine this is the sun. No, better yet, let's imagine this raspberry is the sun. Now, inside the core of this raspberry is where nuclear fusion takes place at 16 million degrees Celsius. That's where light is born. The light, after its birth, then travels in a straight line out of the sun. The problem is, the sun is a busy place. It's very dense plasma. There are loads and loads of particles occupying that space. So what happens is, as that photon of light tries to escape, it ricochets and crashes into more particles, or it's gravitationally pulled in different directions. So on average, how long does it take to escape the sun's surface after birth? It's 100,000 years, which is bonkers, because once it leaves the surface of the sun, it only takes 8 minutes and 19 seconds, more or less. It's like 2 seconds less in the summer than it is in the winter. Just over 8 minutes to travel 93 million miles to us here on Earth. it's a much shorter distance from the centre of the sun to the surface. It's just so busy. I'd kind of like to visit, but only with a really, really safe spaceship. Oh, I'm just reminding myself, I watched a video today, which I'll link in one of my other videos that I created. And this video was pictures of the sun. The sun is such an amazing thing to actually watch. Because when you learn about it, it becomes more than just a bright light in the sky. You see that it's active and there's all these solar flares and other events that, like sunspots and things, that probably I'll explain in another video, but for now, I just recommend you Googling some pictures or videos. Truly, it is mind-blowing when you see that. Oh, I'm nearly out of raspberries. All gone. Now, an interesting thing about that raspberry, not only does it taste nice, but its energy I use to survive. But where did the raspberry get its energy from? Well, the earth. The plant it came from. Now that plant, where did that plant get its energy from? Well, it got its energy from photosynthesis, which is a process, explained simply, that takes light and turns it into chemical energy, which the plant then uses to produce raspberries and to survive. So, where did the light come from to create the raspberry plant? Well, most likely the sun. So I've just eaten sunlight. That means I am part made of sunlight. That's a pretty cool fact, isn't it? If you agree, just show me in the comments. But everything, not just the raspberries, but all living creatures operate and are powered by sunlight, whether it helps them create chemical energy themselves or whether it creates the food that they then eat to get the energy that way. We all rely on the energy from the sun. That's a pretty cool thought. And had we been on any other planet, at least that we know of in this solar system, there wouldn't be that kind of relationship with our star because of a lot of reasons, but mostly because of water. Now, we've looked on other planets with telescopes and we've even sent machines. Some have landed, some have, like the Mars rovers, they actually are still moving across the planet. Others, we've crashed into the planet. In fact, recently we crashed one into Saturn. Cassini, I think it was called. Anyway, that's some kind of exploration. I find it truly inspiring. But I would really like to do something like a mission where we go to Europa, which is a moon that orbits one of the big gas giants. I think Jupiter, if not, it's Saturn. And this moon is similar in size to our planet. And on that moon is an icy surface, but below the surface, there is a liquid ocean. Now, what that liquid is exactly is not drinkable water. I mean, it could be after a really good filter, but either way, it's liquid ocean. Now, I would like to send a robot to land on Europa, drill down with a camera and swim in that submerged ocean beneath the icy surface. How about that? What would we find looking in a place like that? Because everywhere we found water on Earth, we found life. From rivers in mountain valleys where you can't see any mammals around, we find small creatures. Even in Antarctica, we find bacteria still living, plus the odd polar bear and penguin. What don't I ever do? What have you been up to, Meg? Have you been bad-mouthing me in the comments while I share knowledge? Sneaky you, I guess. Alright, well. I wonder if any of you knew each other before you became a subscriber to my channel. If not, you've gained some friendships, not just with me, but with some other people. I think that's pretty cool. I'm trying to clean up this raspberry mess thing. Lovely. All right. Let's see. Where should we go next with this cosmic exploration? Let's talk more about the nearest star system to Earth. We call it Alpha Centauri. Alpha Centauri actually has 3 stars, maybe 2, because maybe the third one is just passing through. Let me explain. There's Alpha Centauri A and B, and they orbit each other, get this, at the same distance as our sun is to Pluto. Just imagine there being a whole nother star where Pluto is in our system. That would be pretty bizarre. There'd be 2 suns during the day, or maybe there'd be one in that direction during the day and one at nighttime. Maybe there wouldn't be nighttime. Just think how that would mess things up for us here on Earth. It'd be pretty cool. And in fact, it's a possibility. I'll explain in a minute why that's a possibility in the future. So back to Alpha Centauri, they got these 2 stars orbiting very closely, plus a third one called Proxima Centauri. That's the one that's closest to us right now. And Proxima Centauri might just be passing through, but it might also be being caught by these other 2 stars, because it's smaller than the other 2 stars, and if it passes close enough, then the gravitational effect could pull it in, and they could become a 3-star system. At the moment, we call it a 3-star system. Anyway, I find that a fascinating example of how stars are moving about. They're not fixed objects like they look like in the night sky. And in fact, in the next, I think it's 50,000 years, 3 other stars will become closer than Proxima Centauri. The closest will be a star that I forgot, Bernard star. And that star is 10 billion years old. That's twice the age of our sun. So it's probably got some wisdom it could pass on to our younger star. Who knows? But anyway, that star will be less than 4 billion light years away. So just imagine an alien civilization orbiting a star that's not only learned how to harness the power of the sun on their planet and learn how to harness the power from the core of their planet and all the other things like tidal energy from the seas, wind energy, who knows what else they'll have on that planet. But they've also learned how to harness the power of their star. A bit like in Star Wars when they use a star to use that big laser thing. That will mess you up. Anyway, imagine an alien civilization that's lived 5 billion years longer than humans have lived. Because we've only been around for a couple 100,000 years, if that. Before that, we were furry apes. Anyway, this alien civilization may be able to change the direction the star is traveling in if it can harness all that power. And they could then direct that star to come towards us after they picked up one of our signals. And then we could have a 2-star system, and aliens could be riding a star towards us. How about that for a piggyback ride? All right, I'm going to have a quick minute break. Why don't you tell me who's your favourite member of Road Trip? Because I know most of you, if not all of you, are Road Trip fans. That was quick. Brooklyn. Brooklyn is a sweetheart. Brooklyn is one of the nicest people I've ever met. Oh, you're all Brooklyn fans by the looks of it. Why don't you ask me a question about Brooklyn and then I'll make up an answer? Or I might tell you the truth. I'm waiting for a question about Brooklyn. Brooklyn is a sexy kid, that's right. Alright, okay. No one's interested in Brook that much, even though apparently he's your favourite. Fine. Well, let's see. Oh, gosh. Andy's a sexy fish. I'll let him know that. Apparently, the boys all watch the channel. I'm very sceptical they're they've got enough free time to watch me now, but they do watch some of the videos. I know that. In fact, I've been on some of their videos. I even made one of their covers. Did you know that? The one that's in Cheddar Gorge. I forget the name of the song, but you'll recognise it because it's got mountains or cliffs, sorry. And I was there filming for the band. Plus, I was running up and down the cliff trying to find good spots. So, yeah, I have a part-time history as a professional cameraman. When did Andy say it? Probably on another social media thing. I don't actually watch anything other than YouTube. I missed Emma's comment just then, but I'll start reading it. Oh, it's on Lively. Oh, cool. Well, they did say they would eventually give me a little fan boost. All right, something about Ryan. What can I say? I've got a lot to say about Ryan, but one of my okay, Ryan used to have a lot of pets when we were growing up. I didn't really take much interest in them, but he had like hamsters, guinea pigs. We had a dog for 14 years. Bless him. Rest in peace. We've had rabbits. We've had I think we had a ferret. Anyway, we've had a lot of these little rodents. And actually, this is going to be a story about me because it's a bit naughty. Me and my friends once were in the sort of zoo that Ryan created, and there's these little hamsters. I'm not sure if I should tell this story. You might think differently. It's in the past. I'm a different man now. Anyway, what I would do is I would get a cushion like this, and showing off in front of my friends, I'd put one of the little guys on the cushion, and then I'd do this. And it was like a slingshot. It would send them up in the sky. Of course, I would catch them. Until one of them went so high, it hit the roof, then I couldn't catch it. It landed on the edge of the sofa, fell off the sofa onto the floor, and bless it, it must have broke its leg. I know. It's awful, but all the animals died anyway, and probably only one or two was because of me. Emma, don't be so harsh. It was in the past. I was only young then, plus I was showing off. What I've learned since is to really appreciate other animals. I mean, I'll kill a mosquito if it's in my room, but if I'm outside, I'll leave them alone because that's their home. Okay, this is the third request to speak in French from Yelena. This is what I know. Bonjour, je m'appelle Robbie. Je joue de football. I think that means I played football this afternoon, which I did at the park. Embarrassing stories of Rye when he was younger. Guys, of course you want that, but if I was to reveal it to you, that would be unfair on all the other fans at Road Trip TV that want to know these stories. So how about this? When I get a following in the tens of thousands, then I'll start blabbing about Ryan. Maybe before, but you can't convince me. I'm gonna wrap this up, guys. It's been fun again. It's very relaxed. I started off feeling a little bit rushed, but yeah, I like these live streams. These are good. I'm gonna be doing these whenever I can. I'd love to be able to say I can do them at a certain time, but every day is a different day for me, which I love. But it also means I won't be able to promise you a certain time. But it will typically be it'll be in the afternoon or evening, except the weekends. Maybe I'll do some morning ones in the weekends. Because obviously, people are at school or whatever, busy work during the day. So not that I am, but all right. No, go do your homework, Brody. Right. Thanks again, ladies and gentlemen, although I'm pretty sure most of you are ladies, for all the support and love. You're the reason I like to make these videos, these extra videos for you. So Well, I think that's enough said. Goodbye, 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 and you'll see me again soon. Look how I've mastered that ending. I kept messing it up, like no joke, 10 times, but I think I've got it now. Adios, chicas.